What if I told you there is an Earth-like planet, 600 light-years away, where the conditions might be just right for life? But what would happen if you actually landed there? Reaching Kepler-22b is an enormous challenge due to its incredible distance from Earth. At approximately 600 light-years away, this means that even if we could travel at the speed of light, it would still take 6 centuries to reach our destination. However, with current space technology, such a journey would take millions of years, making it impossible using conventional spacecraft. Scientists have proposed several theoretical methods that could one day allow humanity to explore exoplanets like Kepler-22b. One possibility is the warp drive, a speculative technology that could bend space-time itself, enabling faster-than-light travel. Another option is the concept of generational ships, where entire communities live and reproduce on a spacecraft over multiple generations until their descendants finally arrive at the target planet. Lastly, cryosleep, the idea of putting astronauts into a deep, suspended animation, could allow future explorers to survive the journey without aging significantly. While none of these technologies exist today, they may one day hold the key to interstellar travel. Once a spacecraft finally reaches Kepler-22b, the next major challenge is entering its atmosphere. Scientists currently do not have direct measurements of its atmospheric composition, but based on its location and size, there are several possibilities. The planet could have thick cloud cover and high atmospheric pressure, similar to Venus, which would make landing extremely difficult. Alternatively, it might have an atmosphere rich in carbon dioxide, nitrogen, or water vapor, potentially creating a greenhouse effect that would trap heat and influence surface conditions. A dense atmosphere could be problematic for a spacecraft, as the friction during entry might cause it to burn up before reaching the surface. On the other hand, if Kepler-22b has a thin atmosphere, it may not provide adequate protection from cosmic radiation, and it could lack sufficient oxygen for human survival. In such a scenario, astronauts would require specialized suits and life support systems to breathe and protect themselves from potential environmental hazards. If a human were to set foot on Kepler-22b, the experience would be vastly different from Earth. Due to its radius being approximately 2.4 times larger than Earth's, its gravity would likely be stronger, meaning that even basic movements could be significantly more exhausting. Walking, running, and lifting objects could all require much more effort. And over time, prolonged exposure to stronger gravity could have unknown effects on human physiology. The planet's terrain remains a mystery, but depending on its composition, it could be covered in vast oceans, rocky landscapes, or even alien vegetation. Because Kepler-22b is located in the habitable zone of its parent star, liquid water could potentially exist on the surface, increasing the possibility of life. In terms of climate, researchers estimate that Kepler-22b could have an average surface temperature of around 22 degrees Celsius, 72 degrees Fahrenheit, a comfortable, Earth-like warmth. However, without knowing the planet's exact atmospheric conditions, we cannot predict whether it experiences violent storms, extreme weather, or dangerous radiation levels. If Kepler-22b lacks a strong magnetic field, it could be bombarded by high levels of radiation from space, making long-term survival highly challenging. Survival on Kepler-22b would depend largely on its atmospheric composition. If the planet lacks sufficient oxygen levels, humans would require spacesuits or enclosed habitats with artificial life support systems to breathe. Terraforming, a process of altering the planet's environment to make it more Earth-like, could be an option in the distant future. But with our current technology, it remains purely theoretical. Water and food sources present another major challenge. Scientists do not yet know whether Kepler-22b has liquid water on its surface, and even if it does, it may not be safe for human consumption without purification. Water could contain toxic minerals, unknown microorganisms, or extreme salinity, making it undrinkable without advanced filtration systems. As for food, the lack of known native vegetation or animal life means settlers would have to rely on hydroponic farming or lab-grown food to survive. If alien plant life does exist, it would be risky to consume without extensive research to determine whether it is edible or toxic. Perhaps the biggest unknown is the possibility of alien life. Kepler-22b's location in the habitable zone suggests that it could support microbial or even complex life forms. However, an encounter with extraterrestrial organisms could be either an opportunity or a threat. There is a chance that life on the planet could be harmless or even beneficial, but it could also introduce dangerous bacteria, viruses, or hostile predators. Without understanding how alien ecosystems function, any direct interaction could pose serious biological risks to human explorers. One of the greatest dangers of settling on Kepler-22b is radiation exposure. If the planet lacks a strong magnetic field, it would be vulnerable to intense radiation from its parent star and cosmic rays. Without adequate protection, humans could suffer from radiation poisoning, increased cancer risks, and genetic mutations over time. Any settlement would require underground bunkers or specially designed shielding to ensure long-term survival. Even with protective measures, surviving on Kepler-22b would demand advanced technology. Oxygen production, water filtration, and sustainable food sources would be essential. Habitats would need to be airtight, temperature-controlled, and shielded from radiation. Energy sources such as solar power or nuclear reactors would be required to sustain human life in an unknown and potentially hostile environment. Without a strong survival infrastructure, life on Kepler-22b could be short-lived. Another major obstacle would be communication with Earth. Since Kepler-22b is 600 light-years away, any message sent to Earth would take 600 years to arrive, and a response would take just as long. This means there would be no real-time communication, making remote assistance impossible. Settlers would have to be entirely self-sufficient, with no possibility of support from Earth once they arrive. Kepler-22b presents an intriguing possibility for future colonization. If the planet's conditions prove to be Earth-like, it could become a second home for humanity, offering a fresh start in a distant corner of the galaxy. However, the technological and survival challenges are immense. Traveling there, establishing a colony, and adapting to an unknown environment would require breakthroughs in space travel, life support, and planetary engineering. While the idea of Kepler-22b as an escape from Earth is fascinating, the reality is far more daunting. If we ever develop the means to reach it, will it be a paradise waiting to be explored, or a deadly world best left untouched? Could Kepler-22b be our second Earth, or is it a world better left unexplored?